for like more people to join. Awesome. Looks like it pays off. Hey everyone, thanks for joining in. We're gonna wait for a couple more seconds for like more people to join. But otherwise, the Fluent contributors are up on the stage. We have Dino, we have Dimitri, and myself. Um, I think we can get started because this space is recorded anyway. So, like, if someone is joining late or later, they don't have to worry about missing out on anything because they can always go back and catch up on the conversations. Um, but before we really start, I think I just want to do like a little bit of a roundup and set the stage for those who might be joining us here for the first time or heard about this Fluent project from maybe a friend online. And they might need some kind of context without going into the details. And second thing to do is kind of like a wrap up or like quick recap of all the major things that happened this week, internally and externally, that you might have seen on our channels, all the announcements, all the partners that we have announced, and what we are doing, like what's happening in the roadmap. I hope that sounds good. If yes, like give me some thumbs up, give me some emojis. Awesome. Okay, so first, I think let's go over what exactly Fluent is, because I just we just posted this that basically like with Fluent you can build on Ethereum using any languages, and someone just commented that, oh, it sounds like an on-chain version of Duolingo. So yeah, that might be the first impression, but I feel like, again, like we're gonna dive more into the parts of it with like more details, but more so, our micro thesis is that for so long, when we talk about Web3, we also see that Web3 has been gate kept with like all these domain specific languages and domain specific knowledge that any user, particularly developers with Web2 expertise or projects with their code bases on Web2 technologies, they find it hard to easily enter the Web3 ecosystem. Or maybe they find it hard to like test grounds without having to change their code bases or without having to go through this steep cost of learning. And so, what Fluent does for them is minimize this learning curve or minimize this friction of all these projects to kind of enter the Ethereum ecosystem. And so, like, that's basically the thing, like, the gist of what we are doing with Fluent. We let developers enter Ethereum's ecosystem, Ethereum's liquidity, and Ethereum's vast community with the tech and languages that they are most familiar with. And again, like as we say, that we are meeting developers where they are, and not having them come to us. So that's kind of like a gist into Fluent's philosophy and the why. But I'm gonna pass the mic to Dino here to like kind of further break down what Fluent is.
Yeah, thanks, Prinza. So the way I'll just share a little bit about how we think about things and where we see our role is in the space, and then kind of set the stage for the different parts of Fluent that we're going to unpack during today's space. So, kind of broadly, the way we see things is there's what 20,000 or so monthly kind of like active developers in Web3 today, and then there's 20 or so million developers in the world. And as much as there's some amazing progress being made for scaling on Ethereum and helping people build on blockchains in general, we think that 10x better developer experiences and new familiar tooling that people don't have as much of a learning curve to use is critical for us to bridge that gap between 20K and 20 million. We just have a long way to go, and I think that there's a lot of opportunities, and that's what Fluent is focused on. And so what are we actually building to kind of help push that vision forward? Because we really think blockchains can do more, and we think that we're just at the very beginning to the types of people and the types of applications that we can actually get building on chain, especially Ethereum. So where does Fluent fit? So there's kind of like three main parts of Fluent that we're going to talk through today. One is the Fluent VM, which is kind of at the core of everything. We have our own ZK Wasm VM, and we can talk a little bit about kind of ZK Wasm and then kind of what we built around that. And then there's the general purpose L2 itself, which is something that we're using this VM to create, which we'll get into as well. And then at the kind of a little bit longer time horizon, we are building Fluent Base, which I'll tease right now, but we'll talk more about what's in Fluent Base. So maybe just to start, I want to first off just pass the mic to Dimitri, my co-founder and CTO, to talk a little bit about the Fluent VM, which him and our team have built and kind of sits at the core of this whole project. So, Dimitri, you want to just introduce yourself for people who maybe this is the first time getting to know us, and maybe talk a little bit about the Fluent VM and our WASM and kind of what sits at the core.
Yes, sure. So, yeah, my name is Dmitry. I'm CTO at Fluent. So, we all the time speak about things like ZK WASM, and what actually does it mean and where is Fluent is right now. I mean, in the this terminology. So, we have Fluent VM. So, Fluent VM is a core of our execution runtime and execution environment that goes along with our Fluent network and Fluent based framework. So this is a place where we combine all this stuff regarding to ZK, to WebAssembly, to execution runtimes, and etc. So it's actually a code base that defines the structure and the runtime of the virtual machine. Also, it defines instruction set that is mostly inspired and built based on the WebAssembly, and it actually supports WebAssembly execution itself, and it can execute whatever you want, anyhow you want, and also it can prove it using our ZK circuits, using our ZK proving model. And we use Fluent VM to define so-called state transition function for the Fluent network. So Fluent network is a general purpose execution layer that runs as is, but we prove all transition that happens inside Fluent network using Fluent VM. And of course, all this is wrapped, all this is possible because Fluent VM is very flexible. It is inspired by WebAssembly, but and it 100% compatible with WebAssembly. So we strictly follows all WebAssembly standards, and any of existing WebAssembly-based applications can be run using Fluent VM. Actually, it's a sort of binary intermediate representation of a so-called binary intermediate representation that is used to store on your, or let's say on your computer. And why it's so? Why actually do we need to have this intermediate representation? We actually internally we call it RWASM. RWASM means reduced WebAssembly. And what does reduce mean? Reduce means that we removed several instructions from the general instruction set of the WebAssembly, just to reduce the size of our proving circuit to make it more efficient to prove. And also we reduced several ZK inefficient structures, more like CPU related structures with a lot of binary operations, I mean bitwise operations that are not friendly to ZK proving. So we optimize it, and using all by applying all these optimizations, we have our WASM that is used as a binary representation that is also friendly for ZK related hashing functions like Poseidon hash, and it's much easier to compute hashes and store hashes. It's much more efficient compared to Kichak or SHA-256 and etc. And how, you may ask, we run Fluent on the Fluent base with Fluent VM, with RWASM, and all this stuff. So it is possible because we support, and why it's efficient actually. So it is possible and it's efficient because we support so-called circuit extensions inside Fluent VM. So what is circuit extension? Circuit extension is, let's say you develop your WebAssembly application using Rust language, Golang language, whatever you want, and you want to invoke, let's say, a keychuck function or SHA-256 function, and you might say that we don't support native keychuck function. So how do we prove keychuck function? It's so inefficient. So we solve this problem by using um, circuit extensions. So we provide a set of special methods that developers can import in their function. And these methods, and once you call this method inside your function, inside your application, sorry, actually it's fun. It's something like a host bindings. So the same as in EVM, you call function update your storage. So it's actually the same. For developers, it's very transparent. But once you call this, and once we create the proof for your application, we automatically replace all these function calls with our lookup arguments. And we actually use external circuits to verify correctness of your Kichak function computations, Poseidon hashing, and etc. So, and we are going to bring support of a lot of different extensions for most common cases. So right now we have support of the most important and most required crypto functions, including Kitchak256, SHA-256. Also, we have support of ECC verification, ECC recover, working on some account structures like Merkle Patricia trees proving, also ZK trees proving, and also we're going to bring support of some native execution SDKs like Vice or mscripted. For Vice, we have very partial like proof of concept support with the most simple set of functions, but we're going to expand this and bring almost native way how developers can run and compile the applications. So, and by combining all these things together, we built a Fluent network that is based on the Fluent VM and Fluent base. Actually, one thing I forgot to mention, what is, yes, I mentioned everything like Avast, Fluent VM, but what is Fluent base? So Fluent base, you may think that it's the same as Fluent VM, but it helps developers to use Fluent VM because it wraps Fluent VM in our SDKs that is friendly with, for example, Ethereum structures, with Solidity structures, and you can easily reuse all developments we have, and you can easily migrate your application and run. And also, we can bring SDKs and adapters for any existing platforms. Like you can run your Web2 application, etc. So there is no limitations for developers at all. And also, of course, by using this scheme, we're going to bring support of more and more languages because Fluent Base is going to be developed on different languages, for example, on Rust language, on Golang, on assembly script or TypeScript, and etc. So there is no limitations. And for example, right now for the Fluent base, for our Fluent VM, we have support only of the Rust language. And from time to time, we're going to bring more and more language and expand our ecosystem.
Okay, awesome. A lot to unpack there. Clearly, I know you went through kind of Fluent VM, Fluent L2, and then Fluent Base. Let's actually back up for a second and and unpack each of those in a little bit more depth and through the lens of like a developer. So just like put yourselves in a developer's shoes, somebody who's trying to figure out what type of roll up or what L2 to use, right? So let's just start with the VM for a sec. I'll probably just rattle off some questions um, to you, Dimitri. So first off, you said RWASM, right? We're using this reduced WebAssembly thing at the base. Immediately after, if anybody's paid attention to all like the EVM rollup debates and all that kind of stuff, how compatible are you, all this stuff, the one natural question is like, how does that actually impact the developer experience? So I'll frame it as a question like, does reduced WebAssembly mean that they don't, developers don't get to interact with like the full scope of what WebAssembly should offer? Like, is this 100% WebAssembly compatible? Are there severe limitations? What does that look like from a developer standpoint?
So, from the developer's experience, there is no any. So, it's also up to. It depends on how we design the interaction scheme between RWASM and WebAssembly. So, for developers right now using Fluent, it's fully transparent. No matter for them, there is no need to modify the WebAssembly binary to recompile it. They just upload the WebAssembly binary as is, and they don't worry about all stuff like RWASM. They about Fluent VM. They even don't know what is Fluent VM, where it presented, and how does it work, because they only know about WebAssembly and they work with WebAssembly. So how does it work actually? We just translate the applications. We use special embedded uh, ahead of time compilers inside, and we translate the WebAssembly application to a bit reduced version. And we're going to optimize this compiler a lot to reduce the proving time that is required to actually reduce your application. And by using the same approach, we actually can bring support of any of existing binary structures. We can bring support of EVM that is under development right now, and we're going to deliver it in a couple of weeks for our development network. And yeah, so that's
Got it. No, it makes sense. So the developer really doesn't experience, they're not limited in any kind of way. Just deploy your WASM binaries as if it was 100% WASM compatible, and then we kind of like solve the rest under the hood, I'll say. That's cool. So you started to talk about some of these other, what we call execution runtimes. You mentioned kind of EVM compatible, you mentioned some other things. um, how should a developer think about this? Like, are there different kind of like modes to use? Actually, before we get into that, let me actually take a step back before this and say we're building this L2 with the Fluent VM. um, can you describe kind of like the different ways that people, the different types of apps that people can deploy on the Fluent L2, on the Fluent network itself? I know we've talked a lot about kind of shared versus sovereign apps, as we call them internally, but maybe you can talk a little bit to that, and then we can kind of unpack each of those.
Yes, yes, of course. So, the first thing I want to mention that you may ask a question. If you have Fluent VM and you build Fluent network using Fluent VM, how do you execute smart contracts? Do you do simulation? And this is actually the tricky thing. Why do we need these ahead of time compilers? Because when we run Fluent network inside Fluent VM, we embed Fluent VM runtime inside itself. So it means that Fluent VM supports nested calls, and it uses nested calls to execute the same RWASM binaries as it runs actually, because Fluent VM runs RWASM, and inside it also runs RWASM. It means that if you run deploy your smart contract, we can do so-called, like we call it circuit acceleration, but it's actually not circuit acceleration, but it's very similar how the acceleration works on your computer. For example, if you run some virtual machine that runs the same architecture, the same hardware architecture as your computer, there's no need to simulate your execution. It can just forward your execution directly on your CPU. And here we do the same. If you run some application inside Fluent, we actually call it shared apps. If you run it inside Fluent, we just accelerate proving process because it runs the same execution in the same instruction set, and we use the same set of circuits to prove it. Our reduced set of circuits from RWASM. And yes, so thank you for mentioning also two different types of applications that we have. The shared apps, it's the type of app that developers can run inside network, inside Fluent, and it is very, very similar how it works in Ethereum today. You just deploy your application and you do native on-chain interaction with synchronous state and etc. and all of the rest things. Yeah, it's not super fast. And what if you want to run something extremely fast, like centralized exchange and proof all computations, and just publish the aggregated proof? So here we were going to bring sovereign or dedicated apps. We right now call it sovereign apps, but the final name is not standardized yet. So the idea of sovereign apps that you can take Fluent Base, you can take Fluent VM, and yes, before I mentioned our circuit extensions, and what you can do, you can develop your application, and you can use our circuit extensions to combine them to think what is the best way to accelerate your application. So uh, how to make your application to be proven in the fastest possible way. And you just develop your sovereign app using Fluent Base, using our SDKs. You compile it to WebAssembly, and you can run it like in somewhere, like on your backend, whatever you want. And you can just publish the aggregated proof to the Fluent, and we can aggregate all these proofs together and verify. And since it's aggregation, it's snark aggregation. Once you publish this proof, you can configure all circuits based on your requirements, based on your needs. And if you want to enable some additional functions, you want to expand the set of Ethereum structures, and you want to work only with Merkle-Patricia trees. You don't want to have Poseidon inside. You want to be very slow and inefficient. Then you can do this. If you want to run something more efficient, like you want to replace all structures with optimize with zk optimized Poseidon functions, you also can do this. So whatever you can imagine, you can run independently from Fluent, and you can use Fluent infrastructure to aggregate, to compute your proofs, for example. You can, by having a computation marketplace, but also you can aggregate all these proofs and publish to layer one. And this is how you can reuse Fluent infrastructure to speed up the execution process of your dedicated applications.
Awesome. I think since we're talking about the app deployment models, Dino, can you go over what are the two types of apps that Fluent supports or the deployment options that any developer might have, given that we have been talking about shared versus sovereign applications?
Yeah, sure. And I'll try to kind of like tie some of this. And Dimitri covered a decent amount of it, but I'll try to tie it to the nomenclature and kind of current mental models that people have today who are building in the space, right? So there's the shared apps, and then there's the sovereign apps. So as Dimitri mentioned, shared apps are just smart contracts. We essentially have just like an enshrined smart contract platform, similar experience to Ethereum or OP mainnet or Scroll. You just deploy them, deploy smart contracts. They're kind of synchronously composable with the other smart contracts. Pretty simple. And just to make a quick note, the type of execution runtimes that we are using for this smart contract environment, um, are do support um, not only some of the WASM-based languages, but also Solidity as well. And Solidity, we're making it so Solidity is kind of synchronously composable with smart contracts in Rust, et cetera, which I'll probably ask Dimitri to get into in a bit. But just to kind of close the loop on sovereign apps, some people like in the Ethereum ecosystem will just call these like L3s. Some people in like the more modular ecosystem will just say like sovereign app chains or whatever they might be. At the end of the day, we kind of look at these from our perspective as just like sovereign apps. Like they're just like state machines that you can customize any which way you want and kind of settle or aggregate the proofs on Fluent L2. So I mean, you can and actually another thing I'll cue for a second and then come back to later is how you can use Fluent Base to customize these sovereign apps. And there's all different ways to do it. We're making like the framework really modular, but we'll get to that in a bit. So um, maybe one thing that Dimitri you could do is talk a little bit about how we're making like Solidity smart contracts kind of synchronously composable with smart contracts in these other languages. Like, how do they talk to each other?
Yeah. So the first thing that we support Solidity, but the question how do we support Solidity? Actually, we have two different ways of how you can deploy a Solidity application. Let's start with the first option. The first option, as I mentioned before, if you remember, we have ahead of time compilers, and we also have support of EVM ahead of time compiler. It means that you can take not Solidity, but you can take your EVM app and run inside Fluent if you want. And of course, it will strictly follow your original API structures, the way how you interact with the storage, it 100% compatible with the same app that runs in Ethereum, in Goerli, whatever, in any of existing Ethereum compatible chains. And this is the first option. The second option, you can take your Solidity. So in the first option, you can also use Viper, for example, because it translates EVM directly. So you can use any language. You can use U language if you want. If you because we support anything that can be translated into EVM. The second option that we support that is possible because of support of Solana compiler. You can take the Solana compiler and you can compile Solidity application directly to WebAssembly. And you can deploy your Solidity application as WebAssembly binary inside Fluent. And both these apps will be absolutely the same with one difference. Of course, the biggest difference is that in the first case, we run simulation of, we translate EVM to our WASM, to WebAssembly, and we run it as is. And in the second option, you translate your Solidity app to WebAssembly. The second option might be a bit more optimal from the usage because of the some because there are some issues with Solidity to EVM translation, and Solidity has much more information inside about your types, how you interact with methods, how you invoke methods, and there are a lot of rooms how to optimize it and make it more optimal. For EVM, you just have your specification, and you must go through this specification and execute your application. You cannot optimize it somehow. But for Solidity to WebAssembly, there are some rooms for optimizations. And how on-chain interaction works in this case. So we, as I mentioned, we have nested calls and we have cross state calls. So something like internal calls. Uh, this is an option when you can in your app interact with all other apps, no matter what language they run. But with only one requirements, you must know, you must be aware of how this app is developed and how it's designed. So, for example, there is some, let's say, Uniswap, a smart contract that is running inside Ethereum network, and we want to interact with this application. And you must find ABI files that defines the number of methods with the input parameters, output parameters, list of events, and all this required information, uh, names of all errors that is used inside to handle them properly. And you must use this to generate your like API files or for example, you can take interfaces of this contract to interact because you must know how to specify the input for your application. And here we're doing the same. If you run your, if you want to interact with some application that is running on chain, you must know the API standards. And here we're going to bring different API standards, but you must be aware of on what language this application is developed. Because if it runs on Solidity, you use our special SDK that is familiar with all API, Solidity API structures, and you can interact Solidity applications from your app. If you know, if you don't, if you have like downloaded your APIs for the app, and you see that it is Rust-based application, then you use different approach to interact with this application. This is how we suppose to implement this.
Got it. Okay, cool. Um, Maybe we can talk a little bit more about Fluent Base and what that experience is for a developer who, um, who might have used like an OP stack or something like that before. Obviously, now we know that the unique aspect of this, in one sense, is the WASM piece, right? All these the different languages that can kind of synchronously compose together, all the stuff that you just talked about. But now, if I'm a developer, I want to build kind of a sovereign app. And just before we said this was very flexible and kind of it's very modular. Can you talk a little bit more to what kind of like options people have when they're trying to build sovereign apps? I mean, this could, you already talked to a lot of the different execution runtimes, so I think that's more or less clear. But what other options do people have? Like, we're going to make this thing very, give people different places to put like data availability, kind of sequencing. So maybe talk a little bit about that.
Yeah, sure. So let's talk about one existing problem that persists today for ZK applications. You have your working Go Ethereum client that produce some blocks, and you want to prove transition of these blocks. To prove this, you just take your computer and develop a so-called state transition function. You can use any language to. So actually, it's not a part of ZK. It's part of all rollups. You must define your state transition function. You can use Solidity to do this. You also can achieve this by using Rust language. That is C++ because they're much more efficient in the WASM compilation. If you are using WASM as a target, and but the problem is that you have right now you have two different applications. One is developed using Golang, the other one is developed using, let's say, Solidity or Rust. And you must all the time synchronize them and make sure that they are running the same code. And also, you might use some function inside, and you must use different functions. For example, let's say even if your app is developed using Rust, for example, even in this case, you cannot just take your Rust application and say, "Oh, now it's state transition function." No, because you need to define the entry point for the state transition function, and also if you compile it as is, there is no guarantee that it's no STD STD compliant compatible, and also it doesn't say a lot about, for example, uh, if you call like keychuck function, it's going to execute keychuck as is. But what if you refer to some native functions that is implemented on your and you import it from like some external libraries like SO libraries or DLL libraries, etc. In this case, it won't work. So what we provide a way how you can use only one code base to define everything. So you can use Fluent base to define your block transition as well as state transition. And Fluent base defines SDKs for doing this. So you can use our SDKs and it automatically replaces all required functions. So for example, we provide keycheck function. And when you call your keycheck function in a native way using your Rust application, we just use default keycheck implementation that can be even accelerated on your CPU execution somehow. But when you execute it as a state transition function. For you, it's the same function. You just call only one function, keychuck 256. But if you execute it as STF, as state transition function, we and compile to WebAssembly, we detect this, and we automatically replace it with our special import function that uh, we use to replace it with our circuit extensions. So when you execute it on your computer as a block transition, as a block execution, you run it on a CPU. But when you want to improve this, we replace it with our circuits. So actually, this is the fundamental idea of the Fluent base. And using this approach, we can bring support of any SDKs, any circuits, and supports any circuit extensions.
Awesome. Yeah, no, that's helpful. Um, and guys, I know this is a lot. We're kind of going through all different components of the Fluent stack. Over the course of the next, month, actually, we'll more than month. We'll be constantly trying to like simplify each of these things, and we'll probably spend write a number of articles and threads and do more spaces on each of these components just to so people understand what the right fit is for them. Um, and actually, on that note, speaking of timelines, we are going to be focused. Let's talk a little bit about how we like sequence this out over time, right? Because this is a broad scope. Um, we are starting with the Fluent L2, so kind of like the general purpose environment. So initially, we'll onboard people who are um, using Rust and Solidity and TypeScript in a smart contract, in a shared state kind of smart contract context. And then over time, we'll start to harden more of the broader scope of functionality of Fluent Base and start onboarding um, applications and projects that want to experiment. And that's probably over the next like couple of months. But we actually do actually, Krinza, do you want to talk a little bit about our little surprise that that we teased before this started? Oh, Krinza just messaged me saying that she can't hear. So um, I will, I guess she's having some technical troubles. That's okay. Um, well, we just wanted to kind of announce that we officially released our private testnet today, actually. And we haven't, done the formal announcements. So everybody in this space is kind of the first to hear about it. We will probably right after this space closes start shipping the announcement and telling the world about it. But yeah, we have our initial cohort of 10 or so projects across gaming and DeFi and a few other verticals who we're onboarding and working with very closely. So that said, we are doing this on a rolling basis. But that said, if anybody here is interested, you want to just get started deploying smart contracts in Rust initially, and then over the next few weeks we'll roll out Solidity and TypeScript. Definitely reach out. You could slide in my DMs, Krinza's, the Fluent account, or fill out whatever on the website. However you want to get in touch with us, we're monitoring it all, and we can chat about what you want to build. So that's a little teaser. I think Krinza's pinging me because she still can't hear. Unfortunately, sorry, Krinza. Yes, we did announce, and yeah, just wanted to kind of wrap on that. We'll see if she comes back, but I know we were going to transition into questions just to close this out. So if you have any, please raise your hand, and Alvaro can, from the Fluent account, bring you guys up on stage. And if not, I think we actually did have a couple of questions that were asked before this started. So I'll pause there for a second. And actually, while we're waiting for if people have questions, Dimitri, was there anything that we missed? Were there any other aspects in whether it has to do with the project more broadly or just kind of our initial implementation that you'd want people to know?
Actually, there are millions of things that I want to mention. But yeah, I think we won't have enough time today to cover all these questions. But the most, so I think it's good as a first, like our introduction of the Fluent stack, and later we can do more technical oriented based on the specific aspects of the product.
Yep. Okay, that sounds good. Krinza, do we have you back? I'm gonna guess no, so I'll probably just go ahead and um, look to either bring people up or just answer the questions that have already been asked. One sec. Krinza, do we have you back? It looked like something happened there.
Yeah, I think I'm back. Yeah, my internet
Yep.
is breaking.
Yeah, you're good. Yeah, we can hear you. We did announce. I'm sorry, I stole your spotlight, stole your spoiler. So we
Oh
mentioned
wow, did
private
we did
testnet.
we did we give all the alphas?
I don't know. Do you have more alpha for me? Maybe, maybe not. I just mentioned private testnet, how we released it. We're gonna kind of send out the more formal like announcements after this. But and if people want to get started with kind of Rust smart contracts right now, and then kind of like TypeScript Solidity really soon, just to reach out and we'll have a chat.
Yeah, I think our DMs are always open if you have any ideas, if you want to build something, if you want to experiment on our private testnet, if you're a Rust developer, if you feel like you want to play around, just go through the developer experience, the performance, and kind of like, I think at this point, our major goal with this very first version of private testnet is just to focus on optimizing what we might be lacking for the public release. So we would love any kind of help. We want to onboard as many developers as possible so that we can experiment, we can fix issues. Because again, like this is a very first version of our developer preview. So I mean, rest assured that we are going to optimize a lot of things, but we also need your support to identify all these problems or loopholes that we might be missing. So feel free to reach out to me or Dino or like anyone else from our team, and we're gonna make sure that you have everything set up for you to get started.
Okay, so it doesn't look like there's questions from the audience, but there were questions that were submitted beforehand. Um, what sets Fluent apart in terms of developer experience? How does it aim to address the challenges faced by developers entering the blockchain space? Yeah, so um, obviously, this is before the call. I think we touched on a number of these things regarding the languages, but let me just add some more color on it. Initially, like we've mentioned, you could start off with smart contracts and these different languages. Obviously, that's there is a learning curve to learning different programming languages, such as Solidity, but it's not like an impossible task, right? Like, I mean, that's helpful. Let's just say that's like 30-40% of the problem. But the bigger problem, which I think we start to address over time, is the reducing the learning curve of even like smart contracts and learning like the blockchain programming model itself, right? So as we build out Fluent Base, and this proliferation of kind of roll ups and sovereign apps starts to happen, and you as we kind of like get more and more use cases and kind of app specific environments, you can start customizing those app specific environments to tailor towards more of like a web 2 native um, developer, right? So like over time what we envision is kind of using Fluent Base. Like, just say you want to build some like highly performant game or something, so you might want to do that in Rust, and the abstractions can be built using Fluent Base, so where a web 2 developer who wants to build this game can really just like program in their almost regular Rust logic using the tools and the libraries and frameworks that they're used to, and kind of just throw it over the wall, kind of like we can get closer and closer to like a serverless experience. If you've ever used AWS Lambda, like that's part of the vision for some use cases, and I think that we can get pretty close to that over time. And so yeah, I definitely think that it'll tools like zk-wasm and Fluent will dramatically increase the accessibility of blockchain development for web 2 natives. So that's one question. If there's anything else that's popped up or comes to mind, guys, just let me know. Crinzel, bro, you too. Let me look at the second one. It was more or less the same question. So that's okay. How does Fluent's integration of WASM on Ethereum impact scalability? Oh wait, no, sorry, that was yeah. They're pretty similar questions, so hopefully that addressed it. I don't know if there's anything else. If anybody else raised their hand, but otherwise, Krins, I'll hand it back to you, and maybe we can close it up or whatever you recommend.
Yeah, I think we had a few people joining or raising hands. So if you want to ask questions, feel free to request us, and we're gonna have you up on the stage. And we are only gonna wait a few seconds because I really don't like awkward silences, just to avoid that. Okay, I think we are all set. But you guys have all the information now. You guys have all the alphas. We haven't posted anything anywhere yet, so we're gonna make announcements. We're gonna roll out documentation. Also, like if the docs are up, the new docs are up. So like if you want to find more information about what we are building, how we are building, all the things that we have discussed in this session about Fluent VM, Fluent Base. You can search it up on docs.fluentlab.xyz. If you have any questions, again, feel free to reach out to us. If you have any ideas, feel free to reach out to us again. Our DMs are always open. We have our community on Discord as well. So if you have any kind of queries, if you have questions, feel free to ask questions there as well to get the immediate response from the team. Otherwise, again, you can just DM us. Awesome. And I think we are all set to close this space as well, guys. Thanks for joining in. It's been great. We're gonna keep on doing this more frequently, so you guys are always updated with what's going on. Maybe like the next version of testnet. If when that comes in, we're gonna do this again. Um, and yeah, I think the next one's gonna be with some of our partners that are working, so you get the feel of like what's the experience building on Fluent. Awesome. See you guys in the next phase. For like more people to join. But otherwise, the Fluent contributors are up on the stage. We have Dino, we have Dimitri, and myself. Um, I mean, I think we can get started because this space is recorded anyway. So, like, if someone is joining late or later, they don't have to worry about missing out on anything because they can always go back and catch up on the conversations. Um, but before we really start, I think I just want to do like a little bit of a roundup and set the stage for those who might be joining us here for the first time or heard about this Fluent project from maybe a friend online. And they might need some kind of context without going into the details. And second thing to do is kind of like a wrap up or like quick recap of all the major things that happened this week internally and externally that you might have seen on our channels, all the announcements, all the partners that we have announced, and what we are doing, like what's happening in the roadmap. I hope that sounds good. If yes, like give me some thumbs up, give me some emojis. Awesome. Okay, so first, I think let's go over what exactly Fluent is, because we just posted this that basically like